All right, this week you guys have 2 tests. Wednesday's test,
Are we filming?
yes, Wednesday's test is no calculator, and Friday's test is all calculators. Okay, we'll just do one problem so we can get it on the video. And then if we have time, we can play a game. I made one game too. Okay, the test is gonna look just like this. What?
Shout out to period number 2.
Shout out to Andrew for rigging the bingo. The bingo was rigged.
So you see number one, you only write the integral, you do not compute it. That's what it's gonna be like now. So don't spend time computing it when you don't have to. Okay, and notice that, look, I'm not even giving you graphs. You guys gotta be able to draw this graph. R is the region bounded by y equal x squared, that's a parabola, and y equal 2x. So by inspection, the points of intersection are 0, 0, 2, 4, yeah? You don't even have to set them equal, it's so easy. Find the volume of the solid when you revolve it about the line x equals 2. X equals 2 is right here. Part A. In terms of x, that means what does that mean in terms of x? That means dx, which means vertical rectangle. Okay, and we're revolving it about the line x equal 2. Now look at this rectangle. If I revolve it around the line x equal 2, is that a disc, shell, or washer? Shell. It's a shell. So we draw the shell in like that. What's the formula for the shell? 2 pi r h dx. dx because the rectangle is vertical. So again, if you label this point x, y right here, what's the radius of the shell?
2 minus that.
Exactly. And the height of the shell is simply the length of the rectangle, which is top minus bottom. 2x minus x squared, and then you add it all up from 0 to 2. If you're doing the integral in terms of x, it's going to be 0 to 2. If you do it in terms of y, it would be 0 to 4. Just look at the y.
2 minus 2x.
What?
2 minus 2x.
No, 2 minus x.
That's top minus 1.
No, he's talking about the radius.
Oh my.
Look, if you label the point, how many times have I drawn this picture?
Oh yeah, that's right.
No, too late, I'm drawing it.
Okay.
If you label this point x, y, that's x. That's, so this is x, that's 2, therefore that has to be 2 minus x, yeah.
I have a question. So for any of these like problems, do you ever put like 2 in the front and like you just change it to like 0? Remember before we would change it to like 0 to 2?
If the graph is symmetric, if the region is symmetric about the x-axis or something. This one, this region is only in the first quadrant only, so you cannot go from.
So are you making the limits from like where the dots are or from where it rotates
The limits
to?
go from the region. See, here's the region.
Oh,
That's
okay.
the
I thought it
region.
was like where the
No,
circle
no,
is.
no.
That's why I was super confused.
You just have to look at the region, because every rectangle you draw is going to generate a shell. So you're just integrating over the region only.
Okay.
Yeah. Don't worry about going around.
Okay.
Okay, I think we need to draw a picture for each one so we don't get confused. So here's the region. Okay, part B, same thing. Revolve it about the line x equal 2, but then now it says in terms of y, which means you gotta make a horizontal rectangle. And which of course means you have to have the equations in x equals form. So this equation, the line is gonna be x equals y over 2. And then if you do the parabola, it's going to be x equal root y. Let's move it on the side a little bit. X equal root y. Now, if this rectangle gets revolved around the line x equal 2, what do we have? We have a washer. The formula for the washer? I, big R squared minus small r squared dy. Why is it dy? Because the rectangle is horizontal. Big R goes from the center to the outer edge. How do I find this distance? Right minus left. 2 minus y over 2. And again, look, dy, that means everything in here gotta have y's in it, right? Small r goes from the center to the inner edge. How do I find that distance? Right minus left. 2 minus root y. And then you add them all up from ring, 0 to 4. See, here's the region. The y coordinate down here is 0. The y coordinate up there is 4. 0 to 4. And then don't do anything with it. Just leave it. Don't try and simplify it. Because if you simplify it wrong, I have to take off points.
Is this what the test is gonna look like?
Yes.
It's gonna take me.
Okay, same region again. Woo! Woo! Take this region and revolve it about the line y equal negative 1 in terms of x. That means you make a vertical rectangle. So if this rectangle gets revolved around the line, is that a disc, shell, or a washer?
Wash.
It's a washer. Wow. Wow. So pi, big R squared minus small r squared dx. So the big radius goes from the center to the outer edge. And again, since we're making, why don't we write the equations in? This is y equal 2x, and that's y equal x squared. So from the center to the outer edge, how do I find this distance? Top minus bottom. 2x minus negative 1. So I'm just going to put plus 1. Small r goes from the center to the inner edge. Like that. How do I find this distance? Top minus bottom. X squared minus negative 1. That's x squared plus 1. And then add them up from 0 to 2. Since we're doing it in terms of x. And then the last part, revolve it about the same line in terms of y now. Okay, so here's the line. Now, if you're going to do this in terms of y, you got to draw a horizontal rectangle. So if I revolve it about this line, what? Disc, shell, or washer? It's a shell. Label that point x, y. So 2 pi radius height dy. Now, the radius is this distance here. So what is that?
Oh, wow.
You can go top minus bottom if you want, so y minus negative 1, which is y plus 1. Or you could just go, okay, if I label that point x, y, this is y, that's 1, so that's y plus 1, right? And then the length of the height is simply the length of the rectangle, which is right minus left. I guess we gotta go to this picture. What is right minus left? Root y minus y over 2. And again, look, since this is in terms of y, it's all y's here. Add them up from 0 to 4. Can we repeat this on Wednesday and Friday? And then, of course, on Friday, you're going to actually have to compute it on your calculator. Wednesday, you just have to write these integrals. So my guess, this is 16 points right here.
Wow.
Your test. All right. Okay, number 2. We're still going to finish early. Number 2. So tonight's homework is the second worksheet, the one that says integrals with the calculator, Kobata.
Wait, you guys are doing that in with the
Yes, these are homework assignments now. 20. These are 10 points each.
in with the first two?
No, you don't hand down in on the second test
Oh wait, so
because you're gonna want to use that to study. Yeah,
the homework is due
Second time.
second test.
the second test.
But this one isn't due till
Well, this one is due on Wednesday, the one we're
Okay.
doing now. But the
Okay.
tonight's homework is due on Friday.
Okay.
Wait.
Yes.
So, would you advise that we do that after we take the first test? Because, like, the first test will look like this. right?
Well, that's- Yeah. So it's up to you. We're gonna discuss it on Thursday.
Oh, okay, okay. But our test on Wednesday isn't gonna look like the new.
Yeah.
It's just gonna look like the one here.
Everything up to this.
It's gonna look like that second worksheet. Friday's test you're talking
Oh,
about.
no, Wednesday's.
Wednesday's test looks like this.
Yeah, so, okay. We
Yeah.
can do the worksheet.
Yeah, you can do it whatever you want. Whatever you want.
I get pictures from Preston.
Okay, now, if you don't draw the graph correctly, pretty much that's gonna be a fatal error, you know. Y equal e to the negative x, right? Something like that? Did you guys get that? You got no calculator, you know. X equals 0, x equal natural log 2, and the x-axis, so here's the region right there. It says, find the volume of the solid generated when r is revolved about the x and then the y. All right, here we go. So, drawing the rectangle, if I revolve it about the x-axis, is that a disc, shell, or a washer?
Disc.
It's a disc. What's the formula for the disc? Pi times the radius squared dx. And the radius is just simply the length of the rectangle, which is top minus bottom, so add them up from 0 to ln2. Okay, you write that on your paper, you get 2 out of 6 points. You want the last 4 points, you gotta compute it. So let's simplify this. Throw the pi on the outside. And what do I do with the exponents here? Because every year it gets students going negative x squared. Every year. No. This is impossible to integrate. It's mathematical improvement. You can't find the antiderivative. But they do somehow. No, you multiply the exponents like that. And then, is the antiderivative of this simply e to the negative 2x? No, because I left the space in the front for the negative half. Right? Because the derivative of the box is negative 2. You gotta adjust for it. Okay, and then that's the least of your worries. Now you gotta plug in numbers. Negative pi over 2. Now, here, let's just write that. E to the negative 2 ln 2 minus e to the 0 is 1. Now, how the heck do you simplify e? How many times have we done that this year?
Power.
Put it to the power.
2 to the negative.
So that's like negative pi over 2. So how do you handle this? You put the negative 2 up as the power, because e to the natural log banana is just banana. So what is 2 to the negative 2? 1/4. And I'm not gonna, I'll leave the simplifying to you, so we can save a little bit of time. You guys can go 1/4 minus 1 is negative 3/4.
Yeah.
And negative times a negative equals a positive.
Why is it? Never mind.
3 pi over.
B. So we got the same region. I need room here. So you got y equal e to the above. So here's the region, but now we're gonna revolve it about the y-axis. So it's not gonna be a disc, shell, or a washer. It's a shell. See? You guys got it. They were the point, that's why. So, what's the formula for the shell? 2 pi radius height dx. Now, what's the radius right there? X. What's the height? Top minus bottom.
E to negative.
E to the negative x minus 0. Add them up from 0 to ln2. You got 2 points right there. Now, of course, this 2 pi can be thrown outside. How the heck do I integrate x e to the negative x? Tabular. See how you're gonna get everything, you know. You're gonna get everything.
Wait, do we have to do integration by parts?
No, right?
Or once?
This is integration by parts.
No, but like the v.
Or the u v minus the integral of v du. Why not?
It's not like
Or ab.
AB. Well, see, I don't know if there's one on there, but why not? Okay, do you guys even remember how to do tabular?
Yeah.
Go.
Even BC, they're screwing up on this easy thing here. The left column, you take derivatives. The right column, you take antiderivatives. So it's, well, in this one, they're both the same, but don't worry. All I have to do is put a 2 or 3 there, and that'll change everything.
Oh no, then you
You did say
just throw it out of the front. Not phase.
Okay, so what do we got? This times positive 1. Negative x e to the negative x minus e to the negative x from 0 to natural log 2. Factor out the constant, and what do we got here? Negative natural log 2 e to the negative natural log 2. I didn't write it correctly. Do that again. Negative natural log 2 e to the negative natural log 2 minus e to the negative natural log 2. Now plug in the bottom number. 0 minus 1. Don't make the mistake of, if you plug in 0, you don't always get 0. Alright, let's simplify. How do you simplify this? What is this?
That's
Just look over here. That's 1/2.
Oh.
Because you gotta put the negative up as the power. 2 to the negative 1 is 1/2. So what is that? Negative ln 2 over 2 minus, what is e to the negative ln 2? Again, put the minus up as the power, and you get 2 to the negative 1, which is 1/2. Minus negative 1. I will leave the simplifying to you from there. You guys can. So, if you get to this step right here, that's going to be everything except the last point. And then all you have to do is, can you add negative 1/2 and 1?
So we have to simplify it more.
Well, least common denominator, right? Come on, you guys know how to simplify fractions. All right, number 3. Y equal 1 over root x squared plus 1. X equals 0. Why am I even writing this down? Mr. Park, I don't know how to graph this. Well, I told you, if you don't know what the graph looks like, plot the endpoints and then a number in between if you need. Okay, what happens if I plug in 0 for x? Plug in 0 for x.
1.
You get 1. Plug in root 3 for x. Are you serious? You get 1/2. You get 1/2. And then we don't need something in the middle. It looks like that. That's what it looks like. X equals 0. X equals root 3 on the x-axis. So here's the region. Part A. Revolve it about the x-axis. So I draw the rectangle in, disc, shell, or washer.
This.
So pi radius squared dx. Now the radius is simply top minus bottom, so that minus 0. Add them up from 0 to root 3. Throw the pi on the outside. And then when you square this, you just get 1 over x squared plus 1. Now look at that. Hey, that's on the list. I don't have to do anything. That's on the list. Tan inverse. So it's tan inverse x from 0 to root 3. See, you're going to get everything on the list. Use substitution, integration by parts, it's all there. Okay, plug in the top number. Tan inverse root 3. Tangent of what angle is root 3? Pi over 3. Tan inverse 0. Tangent of what angle is 0? And I think you guys can multiply that out there. Okay, part B. Again, same region. Let me redraw it. And then now it says revolve it about the y-axis. Come on! So you're going to get the shell like that. Label that point x, y. What's the formula for the shell? 2 pi r h dx. The radius is x, and the height is simply top minus bottom. So 1 over root x squared plus 1 minus 0. Add it up from 0 to the ln 2.
Question.
Oh, root 3, thinking of the last problem. Root 3. All right. How do I do this integral? U substitution. Right? Because look, if you let u equal to x squared plus 1, du is equal to 2x dx. And look, 2x dx is in the integral. So this is a perfect u substitution. So the pi can come on the outside. What do I substitute for this? 1 over root u. What do I substitute for the 2x dx? Right there, du. And don't forget to change the limits, because that would be a -3 error if you don't change the limits. 1 to 4. So if I plug in 0 for x there, you get 1. If I plug in root 3 for x there, you get 4. Those are the new limits. Don't forget to change it. And it's on the list. What's the antiderivative? And don't say natural log. This is like u to the -1/2. So you make the power 1 bigger.
2 root u.
Okay, look, I'll write it for you. U to the -1/2. Make the power 1 bigger. U to the 1/2, and then put the reciprocal in the front. Oh boy. From 1 to 4, factor out the constant. Plug in the top number. What is 4 to the 1/2?
2.
And 1 to the 1/2 is 1, and then I think you guys know how to multiply by 1, right?
But I have a question.
Oh, when you multiply by 1, then you just
No,
leave
no,
it the
about
same.
earlier. Okay, but thank you.
Uh-huh.
So when you said you revolve it around the y-axis,
Uh-huh.
do you just assume that it's you're drawing vertical lines?
Because, okay, you actually can do horizontal lines, but Here, let me show you something. What if you said, I'm gonna show Mr. Park, I'm gonna press in. I'm gonna use horizontal rectangles. But yeah, you can do it because look, if I revolve this about the y-axis, you're gonna get a this. Mr. Park, I like this better. Except you gotta do two integrals because
Yeah, I
look,
did that.
the right minus left changes. See, like now, what about up here? See, right minus left. It's a different equation, yeah? So you can,
You
so
touch
you,
the two lines that stay the same the whole time.
yeah, because over here, see, if you draw the rectangle, see how the rectangle, the top minus bottom stays the same throughout the whole region?
Yes.
So then you only do one integral. Over here, you make the rectangle here, right minus left is one thing, but then when you get to this point, now the right minus left is something else, so you would have to do two integrals.
That makes sense.
But you could, it'll work out, you get the same answer.
And you can
You should, well, if you do it correctly, you should get the same answer. Because I'm not gonna tell you how to do it, you probably wanna do it in the most efficient way, right? No, roundabout,
Yeah.
okay, you might guess?
I already did it.
Alright.
Yeah, moving on. Oh, we got some trig here, people.
Scenic test.
R is the region bounded by R, y equals sine x. Whoop. X equals 0. Whoop. X equal pi. Whoop. And y equal 2. Whoop. Here's the region. Oh, I remember, I give up, you're gonna get a problem like this. Every single year, you know what students do? They use this region here. They use this region here. Don't do that on Wednesday.
Oh, yes.
It has to be bounded by the 4 graphs that I gave you. Is this region enclosed by the 4 things I gave you? This, and that? No, it's this region here. Because pretty much that's gonna be like minus 10 or 12, you know.
Are you serious?
Hey, man, he's a dark.
Yes.
Crazy.
Because look, this has got ABC, this over here. Okay, part A, revolve it about the x-axis. Now this one you cannot use horizontal. Why would you anyway, right, when you got y equals? Anyway, whatever, draw in the rectangle. When I revolve it about the x-axis, is that a disc shell or washer? It's a washer. So pi, big R squared minus small r squared dx. Big R goes from the center to the outer edge. So top minus bottom. 2 minus 0. Small r goes from the center to the inner edge. Top minus bottom. Sine x minus 0. And then add it up from 0 to pi, right? How did I know this is pi here? It says so? Oh yeah, I guess it does. Okay, now how do I do this integral? Well, you control the pi on the outside. 2 squared is 4. And what's the only way you can integrate sine squared? There's only one way. You gotta replace it with the identity 1/2
minus
1/2 cosine 2x.
I know that.
I keep getting that confused, mister. Well, you gotta stop getting confused. Okay, now, what happens when I distribute this minus sign? You're gonna have 8 halves minus 1/2, so that's gonna be 7 halves plus 1/2 cosine 2x. Now, that is not the antiderivative, that's just the integrand. You gotta still find the antiderivative. Because every year, the students, they're going like this, oh, 0 to pi, I'm sorry, minus 4. Because you didn't even take an antiderivative. That's not how the fundamental theorem of calculus works. Okay, what's the antiderivative of this? This one's easy, 7 halves x. And is the antiderivative of this just sine 2x? No, I left the space 4. 1/4. How come 1/4? Because the derivative of the box is 2x. You have to adjust for it by putting a 1/2 in the front, but there's already 1/2, so that's why it's 1/4. Okay, plug in the top number. What do we got here? 7 pi over 2 plus 0. Plug in the bottom number. 0 plus 0. That's an insult. I think you guys can handle the simplifying of that one. Part B. Revolve it about the y-axis. Oh, I like this one. So you got the bridge. Revolve it about the y-axis. So draw in the rectangle. Label the point x, y. Is that a disc, shell, or washer? Duh. 2 pi r h dx. What's the radius? x. What's the height? Top minus bottom. 2 minus sine x. And then you add it up from 0 to pi. Okay, you got 2 out of 6. Now how the heck do I find the antiderivative of this? Well, throw the 2 pi on the outside. Distribute this x in, so 2x minus x sine x. Okay, the antiderivative of this is x squared. What's the antiderivative of that? You gotta use tabular. Tabular. You guys gotta, no, I'm not making it hard. That's like tabular staring you in the face, right? So, left one, you take the derivative until you hit 0. The right one, you keep on taking antiderivatives. And then tick, tack, toe. So, negative x cosine x plus sine x. And notice how it's in the parentheses because it's minus that. So it's minus whatever the antiderivative is.
Oh,
Because I know some of you guys, your grouping symbols are just non-existent. All right, here we go. Plug in the top number. Pi squared minus parentheses. Plug in pi. What is cosine of pi?
Negative 1.
-1 times negative pi. Pi plus sine of pi is 0. Minus, plug in the top number. 0 minus parentheses 0 plus 0. That's weak. I think you guys can take it from there. Yeah?
That's a lot of pies.
It is. And finally, part C. Oh, we've covered about the line y equal to. The easiest one is last. So, okay, here's the line y equal to. What happens if I revolve it about the line? This shell or washer? This. So pi times the radius squared dx. And the radius is simply the length of the rectangle. Top minus bottom. 2 minus sine x. Add them up from 0 to pi. Okay, now the only way you can do this one is you gotta multiply it out. I gave this problem on the PC test. You know what some people did? They just distribute the square. What game are you playing now, Kobata?
Nothing?
Why do you have a game called Nothing now? Notability. 4 minus 4 sine x plus sine squared x. And then again, what's the only way to integrate sine squared? You gotta replace it with the identity. 1/2 minus 1/2 cosine 2x. And then you wanna add the 4 and the half together, I would. 9/2 minus, this looks familiar, didn't I do this problem like as an example or something? I think we did. These numbers are looking familiar, that's why. Now that is not the antiderivative yet, all it is use an identity. Now I gotta find the antiderivative. So anti-differentiating, I got 9/2 x plus 4 cosine x minus 1/4 sine 2x. There's so many places where you can make mistakes. Mhm. What? Okay, that's a minor mistake.
I don't know, so people watching the video.
Video.
Well, if you're following along with the problem, right? Whatever. Pi, plug in the top number. 9 pi over 2 minus 4 minus 0. Plug in the bottom number. 0 plus 4 minus 0. Cancel out the 4's.
No.
Don't be ridiculous. -4 and -4 is -8.
that's silly.
No, because I gave that on the PC test. They just doing crazy things. Okay, we're almost there. 5. R is the region by, now if you're lucky, maybe I might give you some graphs. You want me to give you some graphs?
Yes, please.
All.
Mr. Park, I don't know what this graph looks like. I told you plot the endpoints. X equals 0 and x equals 1/2. What happens when you plug in 0? You get 1. What happens when you plug in half?
Slightly above 1. 2.
Little bit bigger than 1, right?
I think so.
Actually, even if you did it done, whatever, it's gonna look something like this, okay? It does. Anyway, part A, find the area. How do you find the area of this? Drawing the rectangle. What's the length of the rectangle? Top minus bottom. That thing minus 0. Multiplied by the infinitesimal with dx. And then add up all of these rectangles from 0 to a half. Okay, there you go, 2 points. Hey, you substitution or is that on the list?
List.
That's on the list.
Cosine.
Sine inverse.
Sine inverse.
Oh my god.
What?
Oh my god.
Plug in the top number. Sine inverse of a half.
Pi
Pi over 6 minus
Zero.
0. I think you guys can handle that. Okay, part B, we're revolving the y-axis. Of course it's going to be the y-axis. Now when you revolve that rectangle around the y-axis, disc, shell, or washer?
Shell.
Okay, there you go. Label the point x, y. So 2 pi r h dx. What's the radius right there? X. And the height is simply the length of the rectangle, so top minus bottom. That thing minus 0. Add them up from 0 to a half. Just make sure you get the 2 points. Yeah, you don't want to get minus 6. Okay, now how the heck do I do this one? Use substitution.
I see it.
U equals 1 minus x squared. Du equals negative 2x dx. See, look, 2x dx is there. So you can do U substitution.
Sorry.
So pi, throw the pi on the
Being
outside.
a distraction.
What do I substitute for that? 1
It's
over
U
root u.
It's a new substitution.
What do I substitute for 2x dx? Right there, no, 2x dx. What do I substitute for 2x? Negative du. And what are the new limits of integration? If I plug in 0 for x there,
1.
if I plug in 1/2 for x there, 3/4. Okay? Antiderivative, and don't say natural log. This is u to the negative half. You make the power 1 bigger, and you put the reciprocal in the front. From 1 to 3/4, factor out the constant. So you get negative 2 pi times, what is 3/4 to the 1/2? 1/2 power means square root.
Over 3 over 2.
Root 3 over 2 minus square root of 1 is 1. You know, that would be a perfectly fine answer, actually.
Yeah.
You don't, but then see, if you made a least common denominator, you could cancel the 2's.
So we can
I changed my mind. You should make a least common denominator. Okay, I gotta scroll. See, are you guys good at disc, trails, and washers now?
Yeah.
After all the practice?
Wait, that was number 5.
3 problems to go. I'm tiring.
Woo! I'm sorry.
Hey, if you're gonna come to a different class, don't make trouble.
I'm not. This is bothering my study.
Study area. The base of a certain solid is the region bounded by, and please remember the quiz that we took? Remember I said, one of the problems, I said cross-section is perpendicular to the y-axis? Because some of you didn't pay attention to that, you got a fatal error. Anyway, y equal root x, woo! Y equal 2, woo! And the y-axis, woo! Right there. That's the region. Here's the point 14. I'll even write y equal root x there. Cross-section is perpendicular to the x-axis, so that means you draw like this. You're slicing it perpendicular to the x-axis. I guarantee there's going to be one perpendicular to the y-axis. I'll even underline it just like the quiz now. R, What does it say? Equilateral triangles. Come on, this is not the, what's the formula for equilateral triangle?
Root 3 over 4
side squared.
Okay, root 3 over 4 times the side squared.
Wow.
You know.
Why? You're supposed to know that already. The base of the equilateral triangle is lying right on that rectangle there. So top minus bottom. 2 minus root x. That's the side. So root 3 over 4 times the side squared, but it has a thickness to it, 3x. Add all these slices up from 0 to 4. Now how the heck do I do this one? Throw the constant on the side, and then you gotta multiply it out. And never mind distributing the square. Come on. 4 minus 4 root x plus x. This is easy money. 4x minus, now this is x to the half, make the power 1 bigger and put the reciprocal in the front. So what's 2/3 times 4?
8.
8/3 plus 1/2 x squared from 0 to 4. Where am I gonna go? Let's go over here. Squeeze it in here. Root 3 over 4 times, okay, plug in the top number. 16 minus, what is 8/3 times, what is 4 to the 3/2? Hey, this looks like the quiz problem. Doesn't that look like the quiz problem?
Yeah, it does.
It does. 4 to the 3/2 is 8, so 64/3 plus 1/2 times 16 is 8 minus, if you plug in 0, that's all zeros. Yeah, I'll leave the simplifying to you. In fact, I think that's pretty much exactly the quiz problem. Let me know. Okay, 7. Cross sections perpendicular to the x-axis. Oh, it just says write an integral. That's weak. Read those directions now, because if you actually compute it, I'm not gonna give you pity like, oh, Mr. Parker didn't read. Well, that's your problem. What's the point of intersection? What do we got? Y equal 4x and y equal x cubed. Okay, just by looking, don't even set them equal. What's the point of intersection? 2, comma 8. Very good. What? 2, comma 8. Because look, if you plug in 2, you get 8. You plug in 2, you get 8.
Do you just guess and check that?
Yeah.
Just
Or okay,
equal to each other.
Chong, if you don't like that, they just set them equal to each other, and you're gonna get 2.
Good Chong.
It says cross sections perpendicular. I should have made it perpendicular to the y-axis so you can practice. Are semicircles. We're experts at that. Okay, the diameter of the semicircle is lying right on that rectangle. What's the length of the rectangle? Top minus bottom. Now, if you know, and it has a thickness to it, of course, yeah? If you know the diameter of a semicircle, can you figure out its area? Yes, the area of a semicircle is 1/2 pi times the radius squared, right? This is the diameter. So what's the radius? Half of that. Because I remember on the quiz, people don't put the 2 there, they don't put the 2 there either. It's like, come on. The thickness is dx, and then add them up from 0 to 2. You know what, just for practice, why don't we do perpendicular to the y-axis? Because I'm telling you, there is a problem. Let's just throw it in right now, since we're almost done. So, okay, perpendicular to the y-axis, what shape haven't we done? Square? Isosceles right triangle? Let's do an isosceles right triangle. Do you want the hypotenuse?
Hypotenuse, like a child.
Okay, so cross sections perpendicular to the y-axis are isosceles right triangles where the hypotenuse is lying in the base of the solid. So what we need to do is we need to solve for x. So x equals cube root of y. And then x equals y over 4 on this side. And this point is still 2 comma 8. Okay, so how do I find the length of the rectangle? Right minus left. Cube root of y minus y over 4. Now if you know the hypotenuse of a 45, 45, 90 triangle, how do you find the leg? Divided by root 2. Like that. And then how do you want to find the area of this? You want to think of it as half a square?
Yes.
Half a square.
Or do you want to just go 1/2 base times height?
Half a square.
Well, it's the same thing.
Half
Okay.
a square.
Half a square, whatever. Okay, so like that. So what's the area of the whole square? This thing squared, right? So cube root of y minus y over 4 over root 2 squared. But then it's half of a square, so half. Multiplied by the thickness, which is dy. And then I'm going to add up all of these slices from 0 to 8, since you're doing it in terms of y. You got to go from the y coordinate down here to the y coordinate up there. All right, last problem.
So when you do horizontal rectangles, it always has to be in terms, or like you have to change the
Yeah, you got to make the equations x equals, yeah. Okay, finally, I told you this. Okay, this problem is on the test now. This is the last problem. Like I told you, this was in the book. The only thing I'm going to change is this equation. That's the only thing that changes is this
So we only have to
equation.
write the integral?
For which one?
7?
Yeah,
Oh my lord.
it says right there. Right in the integral. On the AP exam too, I'm using the exact same words as on the AP exam. It's going to say, write an integral, parentheses, do not evaluate.
Let's go the extra mile.
But it's a,
Asking for a favor.
yeah, you can, but if you make a mistake, they're going to take off points. They're not going to give you extra credit. It doesn't work like that. Okay, here's y and y equal 9 right there. That's 9. I'm going to revolve it around and you're going to get a bowl. This is the same directions that we have in the book. Part A, I memorized the directions there. Part A, find the volume of the bowl. Now, what did we do? Did we do horizontal rectangles or vertical rectangles?
Horizontal.
Very good. In fact, did I put it here? It says use discs. So here's a disc. Revolve it around. Make the rectangle, it's a disc. So you definitely need to make a horizontal rectangle, which means we got to change the equation from y equal x to the 4th to x equals y to the 1/4 or 4th root of y, whatever you want to write. Okay, what's the formula for the disc? Pi times the radius squared dy. The radius is simply the length of the rectangle, so right minus left. Y to the 1/4 minus 0. Add it up from 0 to 9. Okay, throw the pi on the outside. And what do I do with the exponents here? Multiply. Okay, antiderivative. Make the power 1 bigger. Put the reciprocal in the front, so that's 2/3 pi, right? Don't forget about that pi now. And then I'm going to go from 0 to 9. Factor out the constant. 2 pi over 3. Plug in the top number. What is 9 to the 3/2? Square root it and then cube it. 27 minus 0. 3 goes into 27. So we got 18 pi. There you go. That's the area of the whole bowl. Okay, part B. If H is the height of the water in the bowl, like here. So water is being poured into the bowl, and then at some point, that's the height of the water. It can be any number between 0 and 9. Now it says, if H is the height of the water in the bowl, write the volume of the water in the bowl as a function of H. Now, do you guys remember what we did in the homework?
Just place 9.
Yeah, instead of doing an integral from 0 to 9, you just do an integral from 0 to H. H is the height of the water.
Why?
Because it says, write the volume of the water in the bowl as a function of H. Because remember, what is the 3-step process in a related rates problem? What's the first step? Write an equation that relates the volume with the height.
Oh.
Yeah? So, instead of going from 0 to 9, you simply just go from 0 to H. Now, how is this problem going to change? Look, you just go to this step here. It's going to be the same antiderivative, except instead of a 9 there, you just put an H. It's that simple. So what is that? 2 pi over 3 times, plug in the top thingy, H to the 3/2 minus 0. There you go. This is the volume as a function of H. So in other words, if you know what the height is, you just plug it into here and it'll tell you what the volume of the water in the bowl is. Okay, that's the first step in a related rates problem. Second step, take the derivative with respect to time. So what do you wanna do? You wanna write dv dt or you wanna write v dot? Because they both mean the same thing.
Wait, is this still?
Hmm?
See ya.
So now, yeah, so this is the answer for part B.
Oh, okay.
Now we're doing C. Throw the constant on the side like an unwanted pet, and how do you take the derivative of box to the 3 halves? 3 halves box to the 1 half times the derivative of box, which is either h dot or dh dt, whichever. But if you forget to multiply by the derivative of box,
Wait.
right? Then how do you find h dot? Because that's what you're trying to find in part C. How fast is the height of the water changing? That's h dots. So you have to multiply by the derivative of box. That's the chain rule. Okay, that's the second step in a related rates problem. What's the final step? Plug in the numbers. So since we are trying to find h dot, we just gotta plug in numbers for h and v dot, which are given in the problem. Water is being pumped into the bowl at the rate of 5 cubic units per minute. So where do I plug in this 5? And how fast is the water level rising when the height is 4? That's a dot. So you just type in 4 there. And then can you solve it?
Yes.
I hope so. So 5, no, you know what, let's just cancel already. 3, 3, 2, 2. What is 4 to the half?
2.
2.
2.
So 5 is equal to pi times 2 times h dot. Therefore, what is h dot? 5 over 2 pi. But you've got to give correct units on, anytime you do related rates on the AP exam, you have to give units. This is probably the only problem where you do have to give units. And again, if you're bad at units, what you just got to remember what h dot means. It means dh dt, height over time. If you had to measure a height, how would it be measured? What does it say? Units, and what is the time? Okay, so units per minute. Can you repeat this problem on Wednesday?
Yep.
Okay. Oh, did the whole thing.
Does units per minute?
Wait, let me look. Yeah. Where are you?
Yay! Woo! Yay!
Mr. Parker, one question.
Question.
Can you go over again how you went from B to C?
Take the derivative with respect to time. The derivative of v is v dot.
Oh, so you take the derivative of the whole thing?
Of the whole equation.
Oh, okay, okay.
Yeah. So that means you gotta take the derivative of the left side and the right side.
Okay.
What time does this class end? 45, yeah? Okay, if we are gonna play a game, let me start the upload because I gotta do something after school.